Dr. Anya Volkov, a brilliant but disgraced quantum physicist, lived a secluded life in a remote Siberian research outpost. Her reputation was shattered when her experimental quantum teleportation project resulted in a temporary destabilization of the local spacetime continuum, a phenomenon cruelly dubbed the glitch by the scientific community. Now, she tracked solar flares and dreamt of redemption. Anya's isolation was broken by the arrival of Kai Ito, a young, idealistic systems engineer. He was bundled in layers of thermals and spoke with a nervous tremor. Kai explained that the Global Synchronization Network, a quantum-entangled satellite constellation, was showing anomalies. His analysis pointed to a spontaneous bifurcation within the quantum entanglement itself, and he needed Anya's help. Anya, hardened by years of self-imposed exile, initially refused to join the GSN, seeing it as a reckless gamble with forces humanity didn't understand. Kai persisted, showing her the terrifying data: global communications fractured, weather patterns becoming erratic, and a creeping sense of unease spreading worldwide. If the entanglement collapsed entirely, the results would be catastrophic: the internet gone, satellites crashing, global economies crumbling. Reluctantly, Anya agreed to help, stipulating that Kai obey her strict protocols. They delved into the complex mathematics of quantum entanglement, searching for the source of the instability. Their investigation led them to a rogue subspace pocket, a tiny, ephemeral distortion in spacetime that was bleeding energy from the entanglement, causing it to splinter. Anya realized the solution: a focused quantum resonance, a precise frequency to counteract the subspace pocket and restore entanglement integrity. But the energy needs were astronomical. They had to tap into the very power grid the GSN was meant to enhance. This was the climax. Accessing the global grid was a risky move, requiring overriding layers of security protocols and potentially causing widespread power outages. Governments would likely intervene, shutting down the project before they could succeed. Kai, his idealism wavering, suggested giving up. Seeing the potential for global collapse, Anya refused to let it happen. This was her chance to redeem her past failures, to prove she could make a difference. Using her knowledge of the original teleportation project's algorithms, she modified and repurposed them, bypassing firewalls and siphoning energy from the grid. The focused quantum resonance reached its peak. The research outpost trembled. The power flickered, plunged into darkness, then surged back on. On their monitors, the chaotic graphs depicting the GSN's status began to stabilize. Slowly, agonizingly, the entanglement rejoined, the fractures healing. The glitch hadn't returned. The GSN, though strained, was stable. Global communications flickered back to life. Anya, exhausted but triumphant, looked at Kai. He was staring at the data, speechless. Anya's work was hailed as a scientific miracle. She became a reluctant hero, her past mistakes forgiven. She established a new research institute dedicated to the ethical and responsible development of quantum technologies, ensuring that the pursuit of scientific progress wouldn't come at the cost of global stability. Kai became her lead engineer, his idealism tempered by experience. They continued their work, now driven by a shared understanding that even in the vast complexity of quantum mechanics, human responsibility remained the most important equation. And the world, once teetering on the brink of chaos, breathed a collective sigh of relief, unknowingly saved by the redemption of a disgraced scientist and the unwavering hope of a young engineer. The whispers of the glitch were silenced, replaced by the quiet hum of a world reconnected.